So this will be the second lecture in Panda series, and today's will be like the topic will be more focused on joins and few more topics that were not covered yesterday. So we did the last topic which we did yesterday was related with lock and ilock. So ilock I basically refers to the integer, and in this we used to give the location on the basis of integer, whereas in just simple dot lock we used to give the name of the indexes and the name of the columns, whichever we wanted to select. So that was the basic difference, and it's also asked in many interviews what is the difference between ilock and lock. So just do not confuse, just remember I is basically for integer. So to access any rows or any columns, you just have to simply write integer, uh, and the integer counting for the rows and columns start from 0, and that's plain counting that is done in the computer language starting from 0. That's it. Now we'll be covering in the sixth section as append, concat, and merge. So if you remember the list, we covered a topic, a function called as dot append. So what it did was it was used to add more elements into the given list. And similarly we did concat when we did strings, so it was used to combine two different strings. And similarly the merge is basically moreover all three are uh, being used in a similar configuration, that is to increase the size by adding more data into the given data. So talking about how is it used in data frames, so we'll be seeing it one by one. So for that, let's make a data frame, and the best way was to use a dictionary because it had column name as keys, and the values will be replaced in as the cell values in different rows. So here we are creating a dictionary called as data dict, and with keys id, name, and then we have language. These will be three different columns, and then we have these set of values in the given list, and these will be the values in the rows. Now to make a data frame, we'll be using pd.dataframe and passing this dictionary. And as I told yesterday, this data is equals to writing that thing is a good practice, but it's not compulsory if you have just one single plain argument. So when I run this, it is going to convert it into a data frame, and that name of that data frame is being referred as df1. Okay, just a second. Oh sorry, I have not run this notebook, so that's why I'm getting this error. So we were in the 4.6. It's quite big sheet. Yeah, so now again I'm going to run this, and now you see it's it's running successfully. And what we have got here is uh, three columns. First is id, then name and language, and then indexing is done automatically by the Python, and when it is done from the Python side, it is starting from 0. That is already covered. And we can change the indexing to id by using set index. Now let's keep it the same way we got, and we are going to make another data frame, and that is having id, name and language. The column name remains same, and I'm adding one more value in the row. And you see the number here is 6 and name is Hiren. The id is 6. Okay, now let's run this. This is done. Now to do that, let's recall the list one. We used append. So list one dot append bracket list 2, so, or the element. So it combined the elements into one single list. Now if we do same with a data frame, what's gonna happen then? So in this case, you see the result is 1 2 3 4 5 6. Here we got it. But if you see the indexing, it is 0 1 2 3 4, and then again it's 0. So the problem here is whenever we are going to add more data frames together, the indexing for that particular data frame is going to be copied as it is. So you see here the data frame 2 had 0 indexing for ID 6, and that same thing is getting copied here. So that is the problem here with the append. To solve this problem, we have another solution, and we can write ignore index is equals to true. So what is going to happen here? This, once we have written true here, so it is going to ignore the indexes of all other data frames which is being appended into the first one. So the first data frame will continue the indexing according to that. It will keep its indexing, and it will apply the same indexing in a continuous increment to other data frames which are being added into it. So here we, again, if we do data frame 3, like combining 1 and 2 again, and we are naming it as 3. In this case, if we are writing ignore index is equals to true, then you can see that the indexing is clearly following on the basis of first dataset. Up to this it was df1, up to 4 it is df1, and this is df2. And earlier case we saw it as a 0, but now it is following the pattern of df1, then like it is 5th, not the 0th one. Okay, now let's see another example. Now we have two dictionaries, dictionary 1 and dictionary 2, and most important thing that you should note down here is that the name of the columns are same in either of the dictionary. Okay, so in fact IDs are also same, and names here are A B C D E, but if you see in second dictionary I have interchanged the name, like first here it is B, then C, then D E F. In earlier case it was different order. Same is done with the subject. In both the cases, only thing that is constant is their column name and their IDs. The order of the IDs remains same in the list. Okay, now let's convert them to a given data frame. So that is done. Now we can check our data frame df1. So by typing this, we are getting the complete list of data frame. You can do this way, or you can use the command dot head or dot tail or dot sample. Head will give top 5, dot tail will give bottom 5, dot sample will give random 5 rows. But since here the data set is very small, we are just writing df1, because this way it is going to give us complete rows. Like if it is very large number of rows are there, what is it's going to do is, up to suppose there are 1000 rows, so it will give 10 rows and then dot dot, then last 2 or 3 rows. And now let's see data frame 2, and in this case the dictionary, you see the numbering was same, only the name order is different and subject order is different here. Now if I do second function as concat, so what's going to happen, let's understand that first. Concat function is accepting two arguments basically. One argument that we have already covered in block 1. So access is basically defining whether you are going to apply this function, or you are going to apply this function on which particular identity, whether it is row or it's column. So you are doing this operation row wise or column wise, so it is decided by axis. So if it is axis is equals to 0, in that case it is referring to row, but when we are writing axis is equals to 1, it is referring to columns. So we are passing two data frames, df1, that is this one, and df2 as its list, and that list is being referred by objs, that is basically objects. So what objects we are using? Data frame 1 and data frame 2, and then we are going to concat it on the basis of rows. Now if I run this, you see here, on the basis of rows, what it is going to do is, I'm just telling Pandas to club these data frames row wise. So row wise, it means take this data frame, print it is like as it is, then whatever the data frame comes next should be added as a new row. Okay, the compulsory situation here is the both the data frames should have same column names. Okay, now you see 0 1 2 3 4, this is first data frame, and 0 1 2 3 4, the bottom is data frame 2. Now if I want to column wise, so it simply means that write my first data frame as it is, and then whatever the second data frame is, just write on the right side. Increase the number of columns in that case. Okay, so if we do this, we are going to get the data appended or concatenated on the basis of column. So you see, beyond this is first one, and beyond this it is second one. And more importantly, you can see here the indexing is 0 1 2 3 4. Okay, now I'll give you a homework. What happens if we do not have data this line, like 5F and subject 7? What will happen if we do not have this line? So how it is like the what value we'll be getting here in the fourth row for second data frame? Just do a bit of practice and check what is the result that you'll be getting. Okay, so now up to now we did two functions, that is dot append and dot just a second, dot append, and the second was concat, and the third was merge function. Now before moving to merge function, if you have not watched the SQL videos, please do that, because merge is nothing but joins, which we have already covered in SQL. SQL, we did left join, right join, and then we did outer join, and then we did inner join. So all these things that we have already covered in SQL is more or less same in this case also. When we did left join, it gave more emphasis on the table that was on the left side. When we did right join, the emphasis was given on the right side table, and the merging was done on the basis of right side table. And when we did outer join, okay, it was like focusing on both the sections. And then we did inner join, and in that case it was focusing on the uh, only the common areas, right? If we have two tables that are left and right, so whatever the common portion was there, it was going to give like the merging or the joining was done on those common rows. In outer, we included common and non-common both. Left, we gave more emphasis on left table, and same, like it is same as in SQL or SQL. So suppose again we are naming two dictionaries, dictionary 1 and 2, and we have some values, and in fact here in this case we are not having the same column names also. Okay, so in the first dictionary we have employee ID, second we have employee name, and third one is subject. And in second one we have department ID, department name, and subject. You see, one name is common here. And if you remember in SQL, there also when the join was being performed, it was performed on certain common columns. Okay, so join is basically going to be applied on columns which are same in both the tables. The same concept goes here also. You see here the subject is that particular column which is available in the dictionary 1, as well as it is also in dictionary 2. So I'm going to make these two dictionaries, like converting these two dictionaries into a data frame, df1 and df2. So you can run this and check what is the value inside it. So we'll have employee ID, employee name and subjects this way. And similarly, if we are going to run for df2, we are going to get the same data, only department ID and department name, but the subject remains same. Now, as I said, the merge function. In this merge function, we are going to use three basic arguments as of now, but we'll be using fourth once we decide what kind of join we are going to operate. So we have left, that is referring to what is the left table. Then we have right, that will have the data of the right side table. And then we have a word on, which is going to tell the common column on which this merge is being applied. And then we have another argument that is to be given as how you are going to merge these two. So how will basically take what kind of join you are applying, left join, right join, outer join, whatsoever. So we have this one and this one. Now if I do merge left, like it is, uh, if you see in the how section, we have given nothing. So we can consider it as, okay, we have 0 1 2 3, subject 1, subject 2, subject 3 4 5, and here 3 4 5 6 7. So what is the common here? The common is 3 4 and 5. So what do you understand here? If we are not writing how, so it is basically taking inner join. So that is the default join. If you do not specify what kind of join you are going to use, it is going to be inner join, and it is going to take only the common rows. So the common rows on basis of subject column. So if you go to the subject column, whatever the common values we have, only those rows will be included in this merge. So we have subject 3, subject 4 and subject 5. And for this, if you consider first these three columns, so this is from left table, and then if we consider third, fourth and fifth column, so it is referring to second data frame. But if we specify that we want left join or right join, in that case, the emphasis will be given on this table. So we have used left. So in left table, we have 1, 2, 3, 4 and 5, but 6 and 7 are not there. So 100% we are going to get up to 5, but 6 and 7 is not going to come here because it is not in left table, and due to left join the priority is being given to left side table. And on the same hand, if there is no data for that respective cell or for that respective column and rows combination in the second data frame, that is right side, to which the emphasis is not being given, it will be replaced, that the value, the empty cell will be replaced with a value called as NaN. So that basically refers as there is no data in that particular cell. So you see it is NaN. It is exactly same as SQL which we did. For the right side, we know the priority will be given on the right side table. How we are going to do a right inner join, and in this case subject 6 and 7 are going to be there, but subject 1 and 2 will not be there. And if you run it, you see we are getting prioritized columns, sorry, rows from the on the basis of right side table, subjects 3 4 5 6. This is complete right side table, and whatever the common things we have is going to come on the left, from the left hand side table. So 6 and 7 values were not there in the left side table, that is why we are getting NaN in that. Now, if we specify outer join, what is going to happen? As I said, outer is basically union. So whether it is common or uncommon, everything is going to come. So all the subject 1 to 7 will be having, and the cells for which there is no value, it will be replaced with NaN. Now we are going to do data filtration. This is very important thing, and you'll be using very like frequently in data analysis part, because you have to filter your data on basis of certain conditions. Okay, So let's just first check one code. So yesterday, if you remember, we had Titanic dataset, and out of that, let's remove this first. So if we do this, we are just simply gonna get my Titanic dataset. Okay, because we have not run it, that cell. So let it give few minutes and it will run. Okay, coming back to DF. So we have two methods here. So first, if you just write simply the name of the data frame, it is going to give you all the rows and columns. But then if you specify which particular column you want, you have to give in square bracket. It is same as indexing. So it is going to give you all the data from this particular column. Now I have all the data here. Now if I want to check or apply any condition, I'm going to give any condition here, and it is going to filter on the basis of that condition. But remember, this is a conditional statement, so it will be giving us two types of value. Either it will be true or false. Okay, it's giving error somewhere, that's why it's stuck. Okay, wait. Fine, now we can run this. So let's just first run Titanic data frame, and you see it is giving me whole table, complete table. But if I write here, suppose I want age, so it is giving me the age column. Either you write like this or you can write this way. It is going to give us the same thing, so you need not to worry. These are two different conventions and you can use any. Okay, both are the same. Now suppose you understand like what this thing is going to give. This is going to give all the values from fair column, and I'm going to check if it is greater than 15. First let's see our data here. Df dot head, not head, I'll use sample, and let's take randomly 5 samples here, 5 different rows, so we'll get an idea. So yeah, so we have a fair here 24 and we have a fair as 15 here. So I'm going to check all the rows which are having fair equals to or greater than 15. Now if I run this, I'll be getting a boolean answers: false, true, false, true, false, 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 true, true, true. So true means all those rows have fair greater than 15, and if it is false, that means those rows do not have a fair greater than 15. And to cross check, let me change this as head. And you can see clearly the first row is having lower value, so this is 7.25, and second is having 71. So that is why we have got false here, and in second case, which is greater than 15, we have got true here. Okay, now let's go down here. Now we have done this. Now if we pass this true and false as an argument to the whole data frame itself, so we are passing this true or false value to the data frame itself. So what it means, if it is true, give me those rows from the data frame itself. So now we are going to get all the rows with value for which this condition is true. So that is how we are going to check it. Suppose instead of this, if I want to see the name of all the people who have age above 18, so in this case we'll have, now if the age is above 18, we'll have all those people here. Okay, if we want to do less than 18, we can do this way. You see everybody's age is less than 18. Now there is another function called as count, which we already did yesterday. So what it is going to give is, it is going to give the number of people, where is the age, number of people who are having lesser age, specifically lesser age here. Okay, this is for whole data frame, but you can also check it for one specific column also. Now I'm going to check two different condition, and so first I'm going to check if the fare is greater than 15 and embarked, that is the name of the column, is not equals to C. So the values in embarked we have S, C, S, S. So if it is not C, not equals to C, then all those rows for which embarked is not C and the fare is greater than 15, give me all those rows. So that is multiple conditioning. Okay, so now we get this answer. Now let's go to some high level of indexing. Okay, and why is it required, we'll understand a bit. So suppose we have company here, Google, it's a dictionary. Okay, in the name of company we have repeated values here, Google and Microsoft, three times. So here we have got revenue, we have got employees, and then we are making a company data frame called as CMPDF on the basis of above dictionary, so which will have the data of companies. So if you run it, you can see Google, Microsoft three times, then different years and the number of employees. But and this is index, right? Now if I want to make two columns, that is company and the year as index. Okay, I want to make two different. Up to now we did one column as an index. So why are we going to make two different column as indexing? So you see in the company we have just two types of categories. So under Google categories we have 3 years, and under Microsoft category we have 3 years. So when we need such kind of bifurcations, we go for multiple indexing. You'll understand with the result here. You see, now our table is grouped into two different categories. First, it is grouped on the basis of company, because we have written keys is equal to company, and then it is getting in index on the basis of year. And if you remember, in the log and ilog, what we did is we used to give the positions, or you can say the name of the columns or the name of the indexes to get the data from any place. Okay, so if we give cmpdf dot loc 2009, it is going to give you some error. Why is that? Because this is double indexed cell. This is a double indexing here, and we are just passing one single index, so it is going to fail, or it is going to give us error. Whereas if we pass two times, like two indexes, dot log Google and dot log the year, now we are going to get all the employees from Google in the year 2009. So if you have done double indexing, you have to write all those indexes to get the answers from log condition, not condition but log function. So this is one way. Other way is we can use dot access function. So suppose in this we are going to access Microsoft data at a company level where index level is 0. So level is company and the key is Microsoft. If we do that, we are going to get the employees from Microsoft section. The company was Microsoft. So you see key here, right? Key is basically, this is one of the value in the cell of this particular column. So this is one value. And if we go down again to the code, and the level is company. So Microsoft is under what level? It is under the name of column company. Okay, you can see this. It is giving me just for the Microsoft. If we want for the 2009, all the data for the 2009, now we'll be getting for the Google as well as Microsoft. In 2009 year, for the Google we have these many employees, and for Microsoft we have these many employees. Now let's load another data set called as tips data set. So this data set basically contains uh, a data set of a restaurant where multiple people visit at different time, and it is comprised of like groups or single people. Single person is going to visit, or a group of people are going to visit it, or sometimes there is a party, corporate parties or anything, and people are when they are leaving they give tips. So it's something like that. So let's see. And this data set is available with cborn, and if you remember yesterday's lecture we imported cborn as sns, and the command goes as sns dot load dataset. Okay, so this is a command to load the dataset that is already available in cborn. The name of the dataset is tips, and cache is equals to true, and whatever the output from here, it's going to be stored into a variable called as tips. And that tips is basically since it is a data set, it is the for data type of this is a data frame. Now, since it is a data frame, we can use dot head function. We are using dot head and storing that 10 rows only in again back into the tips same name. The data frame old data is getting replaced with only 10 rows. And if I want to see that rows, so this is top 10 rows. So in that we have columns as total bill, that is the bill of the customer, what is the tip they have given, what was the sex, and what if they were a smoker or non, at what time of the day they have come, and like time and date actually, sorry, and then size, like how many people were there, something like that. Now I'm doing multiple indexing. I am going to filter this on the basis of sex and size. So what it is going to do, it is going to categorize my table on the basis of male and female, and then on the basis of size. Size is basically the table size, what size they have occupied. Now if I run this, now you see female and male. When this table of size was 2, okay, it was mostly covered by females, and the total bill on an average was 16.99. Then the tips they gave was 1.01. And similarly when it was a male, and the size of table, this is each individual row. For male we have 3 entries, 3 3 2, and these were the values. And similarly when we have female, for 4 size we have different entries. And now we are going to use sort index. Now we are going to sort on the basis of index itself, and we have double indexing here. Okay, so first is male and then second is female. The problem here was we were getting male and female for 2 times on the basis of size. Now what it is going to do is it is going to sort it on the basis of index. So first it is going to sort on the basis of um, 6, and then on the basis of size, and you see 2 2 2, then 3 3 3 4 4, all combined for the male. Then for the female it is 2 and 4, and it is sorting in that way. We can also use like dot access function, and in this case the key is 2. 2 is basically referring to the size, and you see again it is in size. So if I run this, I'm going to see when the table size was 2, what were the condition for male and female. So this is the data. So if you feel like you're getting confused, do not worry. You can in like major cases you will not require multi-indexing, but in case if you require, you can always do this way. Otherwise you can use dot access function. So you see here what we are doing basically is we are grouping the data. Okay, we are grouping the data on the basis of different indexes. So there is another way to do that, and that is group by command. Okay, so again we are loading our data set. Now in this I'm not taking just top 10 rows, but we are taking complete data set, and this is the first 5 rows. Now group by, the function goes by group by, so you have to write data frame dot group by function, and now you are grouping by what particular column. So I'm grouping it by time column. Okay, I'm grouping it by time column. Now if I run this, I have got no values. Why? Because it just grouped it and we are not performing any action on that. It is just grouping it. But if we want to perform any action, we have to give any function name. Suppose we want to count on the after grouping. So group it by time and then count it. So it is going to count like lunch in the group, sorry, time we had lunch and dinner, two variables. So if it is going for the lunch, the total bill that they got was 68, and in the dinner they got 176. So that means in the dinner time they had higher tips, they had higher bill. Sorry, I'm just confusing you. I got it wrong. So count is basically the number of rows. In the lunch, we had 68 rows, and for the dinners, we have 176. And since the number of rows is higher here, we can deduce that people came in larger number in the dinner time. Now I'm using dot min function, so it is going to calculate the average. So this is the average of the bill that they got in the lunch time, and this is the average of the bill that they got in the dinner time. So since the number of people uh, that came in the dinner time were large, so we are getting large here. But you see, the difference is not that high here. Okay, on an average, if a person goes for lunch, he's spending $17, and on an average he's giving tipping for 2 rupees. Okay, and approximately two people are they are taking a table of two, and when it's coming to dinner, it is like they are taking on approximately three, a table of three, and the tip they are giving is moreover same in lunch and dinner, but for the dinner, since the number is high, we are getting 3 point, but you can consider it similar. Now we are grouping it by time again, and then we are using aggregate function. So what is going to happen when we are going to use aggregate function? We'll understand it later. So first understand this inside one. So this is a dictionary, since we have used curly braces. So first we are going to aggregate the bill part, and in that bill part we are going to give two things. First is minimum and then maximum, and then second part is tips. In that tips we are going to find the sum of the tips. Okay, now if I run it, first I'll be grouping it on the basis of time, and then total bill is divided into two parts, minimum and maximum, and then tip is divided as one single column as sum. The sum of all the tips we got in the lunch time was 185, and in the dinner time we got 546. So minimum bill that was generated in the dinner was 3.07, and whereas the maximum was 50.81. So this can be done for uh, tip also, right? We can do the same for tip also here. If I copy this here, and if I, sorry, now if I run it, so tip is also getting divided on the basis of minimum and maximum. So maximum tip they got in the lunch is 6.7 and minimum is 1.25, whereas in the dinner time it was 1 and 10. So I prefer group by method over any other tool which we did, like multiple indexing. Personally, I feel group by is better, but it is all up to you. Like you can use either of those things to analyze your data. Then we have some very important functions that are used to handle your data or analyze it, uh, to find out what are the counts, what are the unique number of elements available in. So dot unique function is going to give us the unique values. Okay, what are the different unique values you've got? N unique is going to give you the count of those unique numbers. Value underscore counts is going to give you a series containing the counts of unique values. Dot apply is going to apply a function along the axis. Sort values is basically going to sort the values, okay, on the basis of any given access. So suppose this is people, this is a list here, and we are making a data frame out of it, and the name of the columns are name, score, and blood group. Okay, well, let's run this. So this is my data frame with the blood group. We have name, score, and the blood group. Now we are using dot unique function. So dot unique function over blood group. Okay, so first we are selecting the column blood group and applying dot unique on that. So if you go to blood group, we see that there are three different sections here: O plus, A minus, and B plus. So these are three different categories. So it will dot unique is going to give us O plus, A minus, and B plus, whereas dot n unique is going to count how many O plus are there, how many A minus are there, and how many B plus. So it is basically going to give that three different categories are there, not how many, but how many types of categories are here. So here we have three types of categories. You see dot unique, this is the result of dot unique, and this is the result of the count. It is counting how many unique values we have got. So underscore dot value counts. Okay, so this is the earlier one. So how many we have O positive, how many A negative, how many A positive. So it is going to count the values of these groups, okay, these categories. So this is a function which is taking an argument x, and then it is returning the double of that number. So we are making a new column called as score times 2 is equals to, new column is this, and the value inside that column is whatever the current score is getting multiplied by, to apply dot apply times 2. So what it is doing is dot apply is basically applying a function. The name of the function is times 2 over the elements of people df score. So the values in the given column called as score, take those values and apply a function on all those values, and the name of the function is times 2. That is how you do. Other way is you can use lambda function here if you do not want to make any function here, so you can also change it with lambda function. So lambda is basically one-liner functions. So now if we do this, a new column will be added into our data frame, and that will be named as score times 2. Yeah, here it is, score times 2, and it is the double of this score. Now if I want to sort, we will be using sort underscore values, and sorting is done by which particular column? By score, sort by score, and then we run it, and you see the data is sorted here. To see how whether it is sorted, or you can focus on the indexes here. So first we have 1, 3, 2, and 0, and if you go by score, it is done in ascending order because we have put ascending is equals to true. If you do not write it as a true, it will be in descending order. Now here what we are doing is we are loading another CSV file from that is UCI air quality data, and we are saving that into air df. That is the name of our data frame, and now we are checking air df dot head, and in this is the type of data. In this we have date, time, like CO is carbon dioxide, then pt08.s1 something, nmhc, c6s6. These are the different nitrogen, NOx, nitrogen oxide, monoxide. So we have different values here, and these are the columns. Okay, now let's use the function dot info. So it is basically going to give us the detail of our table. So this is the detail of our schema or the table. Okay, now if we give dot head, it is going to give us first row if we have given a number here. Here we are using importing a function, a package that is going to suppress the warnings if we have any. Okay, so I'm just gonna run it. Warnings is basically, sometime you see okay, this code is not working properly sometime. So it is not basically an error. The code will run, but you will have some warnings. So to suppress those warnings, we had one case here where we had warnings. So this is the case of error. This is not warning. No worries. In that output, you will see it is written as warning, so you can easily figure it out. So to suppress that warning, we'll import warnings and then we'll write warnings dot filter warnings and we'll set it as ignore. Okay, so in this column you see we have date, and data type is object. So what we are going to do is we have to change the data type to date type, because that is the correct format of data type of date, but here it is object. So first we have to convert it back to date format. Okay, so to do that we use the function to date time. PD dot that is available with pandas. So PD dot to date time, and will pass the data frame and its column. So AirDF date. So the column date of AirDF, convert that to date time, and then again store it back to the same column. So I'm doing that, and now I'm going to check. So again we have a time column here. Okay, we have a time column here, and it is also object, so we can change it also. So AirDF time, and here we can give, this was all like what kind of time we are having. So if you go to the first value here, time is 18.00.00. so first is hours, then we have dot because we have dot in our like cell value, then percent %m, that is, then we'll have minutes, then dot, then percent %s. So it is going to convert it into time format. Now if we check the information, we'll see clearly the date and the time have new data type, and that is date time data type. So this is how you change the data type to date data type, and for that we use to underscore date time. Now just see this. So this means go to the column date, take the first row of the date column. Now dt dot day 0. Okay, now let's see what is going to happen. Dt dot day 0. So dt is the function and dot day is a function, and this is going to give us the day. Similarly for month we will write dt dot month 0, and for year we can write dt dot year 0. And if we run it, you see the day is 3, month is 10, and year is 2024 for the first row data. So first row we have 10 3 2024. So we get 10 3 2004, not 24, 2004. Yeah, 2004. So this way we can, so if you want to write this long code, so better to write it in stepwise. First write this much, then dot head, get the first row, then get to the first element. To get the first element you use this, and then we are converting that to date format. So this is the step. dt dot day dot n unique means count of the unique dates, count of unique months, count of unique years. So this is dot n unique. Number of unique days 31, number of unique months 12, and number of unique year basically. So it means this particular data set is of 2 years, and that data set has data for 12 months and 31 days for each month. So means it is giving the maximum, but it could be 30 or 28 also. Now see, there are few functions that is used for day of the week. So day of the week means Monday is referred as 0, Tuesday is referred as 1 2 3 4 5 6, something like that. So for that we can use the function .iso calendar, day of the week, okay, and the day name, day of the year. So these are different time series functions which you can Google always when you feel that you need it. So dot week is going to give which particular week is that in the year. So we have 52 weeks, and out of that 52 weeks, this is 40th week. For whatever date we are selecting, the first row is 40th, falling into 40th week. And this week function is available into ISO calendar function, and this ISO function, calendar function, is available inside DT function. Okay, so import date time, somewhere I might have written import date time. I think I have written in the start. So that was for dates, date of the day name, day of the week, day of the year. Okay. Similarly, we have for time. If we have a time, we can fetch out the hour out of it, minute out of it, and second out of it. So we'll get 1800. So first time was 1800. Similarly, we can change the format for any date, time, or anything. And timestamp is basically going to give us current time. Okay. And here we are giving okay, sorry, this is not that what I told. So timestamp is a variable here basically, and it is storing some time, and then I'm converting it to date time as a time, and then which format, hour, minute, and second. And then I'm comparing if the time is lesser than this particular time, collect all those columns, and then find the shape, means count all the rows and columns. So we have 35 rows and 17 columns. Similarly, we can do for the date, and then we can dot tail, means we can print the last 10 rows or 5 rows of that. So that was all in Python uh, with Panda section. This was like basic Panda we have covered. More will be done in the advanced coming sections. As it is required, we'll be covering all those lessons. Thank you so much.